Okay, so now we're going to go ahead and move along to simplifying roots with variables. What that means is inside the square root or the third root or the fourth root sign, we're not just going to have a number, we're going to have x's, y's, and z's. So as you can see on our first example right off the bat, it looks a little different. We've got x to the 5th, y to the 6th, z to the 9th, and we need to figure out its factors. Normally when we do that, we have to think what two numbers multiply together to equal 50, etc. It's not so difficult with x to the 5th. We know the factors. It's 5x's. So we're going to go ahead and write it out. X times x times x times x times x. Remember, each of those lines is basically the same as a multiplication. Now we're going to do the same thing for y's and the same thing for z's. Now, because we have a square root, we're going to look for pairs. I have one pair of x's and I have a second pair of x's. Normally when we do a problem like this, we would write x times x. Well, x times x is just x squared. A lot of people think, oh, I have one set of x's, I have a second set of x's. That's why I end up with x to the second power. We still have that leftover x which needs to go inside. You also notice that we have to do the same thing for y's. One set of y's, a second set of y's, a third set of y's. Because I have three sets, it's like y times y times y on the outside, which is y to the third. For the z's, we have the same process. One set, a second set, a third set, and a fourth set in this case. So that ends up being z to the 4th with that one leftover z on the inside. Okay, right off the bat, go ahead and give this one a try. Pause the program. When you finish the problem, hit unpause it, hit play again, and we'll see if your answer is correct. Okay, so hopefully you finished the problem. We write x to the 7th, y to the 6th, and z to the second power. Notice 7, 6, and 2. Be very careful that you're counting to double check you have it right. Biggest mistake, people write out 6 of them, think they wrote out 7. It's going to change the rest of the problem for you, so be very careful about that. Otherwise, pretty simple process. We're going to count pairs, and again, that's because we have square roots. You'll notice we have 3 pairs. I use different colors. You can do all circles. You can do little boxes around ones to group them differently. You can kind of squiggly lines around some of them. The idea here is to notice that there's 3 sets. That's then going to equal x to the 3rd with 1 left over on the inside. Same thing for the y's. We end up with 3 even sets, which ends up being y to the 3rd, nothing left on the inside, and 1 set of z's, which equal a z on the outside. Notice there's nothing left for y's and nothing left for z's. That's totally fine. I know my square root sign's way bigger than it needs to be. That's not a problem. I think it's a great idea to go ahead and write that square root sign right off the bat so you don't forget it, so you think about what's inside and what's outside of it. Okay, right off the bat, hopefully you notice that something's different here. This is the third root. It changes everything that we do only in the sense that instead of counting pairs, now we're looking for 3 of them. So I'm going to follow the same process. 6 of them, 7 of them, 5 of them. I'm going to look for sets of 3. I have 1 set of 3. I have a second set of 3. That doesn't equal x to the 3rd on the outside because it's a third root or anything like that. It's still going to equal 2. Right off the bat, like I said before, write your symbol. Make sure you include the 3. Very common mistake. People forget the 3. Don't do that. Attention to detail is very important in algebra. Changes the answer. So now we're going to have x and x, 2 sets, which is x squared. Y's, I have 1 set, a second set, and you can see 1's left over. So I get y squared with 1 left over inside. Nothing changes except that little 3 on the outside and how we're counting it. Now going on to the z's, I have 1 set with 2 left over inside. When you have a third root, you could have up to 2 left over. When you have a square root, you can only have 1 left over inside because otherwise it would have come out. Okay, similar to the last one, you're going to go ahead and try this one. Go ahead and pause the program, hit play when you're done, and we'll check if your answer is correct. Okay, so now we're going to go ahead and write it out. Again, we're looking for 3, 2 sets of 3, with 2 left over inside. 1 set of 3 y's with 1 left over inside, and 1 set of 3 z's with nothing left inside. Okay, so now what we're going to do is we're going to go ahead and put it all together. What that means is we're going to put constants with variables. So as you can see right off the bat here, we have square root of 20, but we also have x to the 5th. It's a simple example, but you can see right off the bat that there's two things going on there. My rule of thumb, keep them separate. You know how to solve numbers. It's pretty much the same, but it's a little bit different than x to the 5th. So we're going to just treat them separately. We're going to start with the number first. That's 2 times 10, and that's 2 times 5. Very straightforward, very simple. Now we're going to go ahead and look for a pair. We have a pair of 2's. So when we put our square root sign, that 2 is going to go on the outside. 5 left over stays inside. Okay, we just got done practicing how to do x to the 5th. Write 5 x's out. Look for pairs, one set, a second set. That equates to x to the 2nd. And left over on the inside is that 1 left over x. Can you organize this all at the end? Yes, it works pretty much the same. However, I prefer, as a rule of thumb, to treat numbers and x's separately when you're solving them because they sometimes have slightly different rules. This is true with exponents and other things as well. Okay, so even though we just did one example, you guys have gotten a lot of practice right now, so I want you to pause this and try this one and see if you're able to get the correct answer. Okay, so I'm going to go through this rather quickly. Remember, it's not super important that you're getting the exact same factors I am. It's more so important that at the end, at this point right now, you have the same numbers. 5 2's and 1 3. That will always be true no matter which way you break down the numbers. So when we look at pairs, we got one set, a second set, brings a 4 outside. Left over, we have a 2 and a 3, which make a 6. Now we're going to break down our x's. Sometimes people like to do the x's first. So they'll say, okay, I have a pair, I have a second pair, I have a third, and a fourth, which makes x to the 4th. Nothing left over. You can do it separately. It doesn't make a big difference. Some people like to do it this way so they don't get confused with all the letters down there. Next, we're going to have y to the 3rd, one pair of y's with 1 left inside. Okay, so we're going to go ahead and try this one out as well. So pause the program, give yourself a couple minutes, try it out, hit play. Okay, so again, rather quickly, to me, easiest is 2 times 100. Remember, at this point, I could do 10 times 10, but I'm breaking it down completely just so you guys can see. Don't worry about just as soon as you notice a perfect square that'll end the problem, go ahead and find it. So now we're going to have 2, which is going to come outside, as well as 5. 2 times 5 is 10. And on the inside, we still have that 2 left over. Okay, now we're going to break down our x's and our y's. One pair, second pair, 1 left inside. And y's, 7 of them. One pair, a second pair, a third pair, x to the 3rd with 1 left. Sorry, y to the 3rd with 1 left inside. Now, one rule of thumb that you can do here to kind of make these easier for yourself as far as whether something will be inside or not is just to look at the power. If it's an odd number and you're taking 2 of them, you're going to be have a leftover one. If it's even, there won't be anything left over. So, for example, if you have like x to the 6th, you shouldn't have anything left inside. If you have y to the 6th, you shouldn't have anything left inside. 8, 10, same thing. Not necessary for you to remember that because obviously you can just count. It's very simple. But sometimes these shortcuts do help us out for those of us that can kind of get ahead on things like this. All right, so this is the last example on this. What we're going to go ahead and do now is if you guys look right below this video after you get out of maximize mode, you'll see that there's a code to go to a quiz. It's basically an online quiz. It'll have about 10 examples for you to practice. Starting off very simple and getting to this sort of problem at the end. And I want you to go ahead and take that. You can only take it once. You can go back and change your answers. It's not going to save your scores, it is going to save your scores no matter what, but it'll give me some feedback to know, do we need to keep working on this or are you guys done? So go ahead and do that. As soon as you finish that, down below you'll see there's like a little form for you to fill out. That's just to make sure I get any feedback from you guys on making sure you understand the process, not just how to do some problems, as well as making sure you give me some feedback if there's anything that was still confusing you, so I know whether, like I said before, whether to go ahead and continue with this tomorrow or whether we can move on to something different. So go ahead and do that now.